Hello, and welcome to the third installment of our ongoing series of videos examining how to successfully leverage the SOSA technical standard. I'm Mark Littlefield, Director of System Products at Elma Electronic. In this video, we will be looking at two often overlooked topics in the SOSA technical standard. First, we will look at the role that coax and optical-based connector modules play in the standard, and we'll finish with a look at how system management is implemented in the standard. The latter will actually introduce us to the SOSA software module architecture through its role in system management. In future videos, we will explore SOSA modules more deeply. So let's get started. The various VITA 66 and 67 documents define a set of blind mate connector modules for OpenVPX. They are said to be blind mate because they are very tightly defined and the two connectors seamlessly mate when the plug-in card is inserted into the backplane. Like any connector, there are two parts: a backplane connector fitted to a hole in the backplane, and a plug-in card connector attached to the card PCB in a gap in the connectors called an aperture. We won't go into the details of VITA 66 and 67 here. You can watch our OpenVPX tutorial number 3 video to learn more about that. In this video, we're going to focus on what SOSA uses from those VITA standards and the rules that SOSA lays out for their use. The VITA 66 and 67 documents define many different options for optical and coaxial connections. SOSA limits those choices to a subset from the VITA 66.5 and 67.3 documents. This slide shows a few of those connectors. As you can see, they include coax only, optical only, as well as hybrid optical and coax. They also include options for both 50 ohm and 75 ohm contacts. Each slot profile with an aperture in the SOSA technical standard has a table outlining the permitted connector modules for that slot profile, along with VITA 65.0 and 65.1 details, like the dash number assigned to the connector and the section numbers that define the coax and optical connectivity for each connector module. The connector modules marked in orange are considered legacy and are not recommended for new designs. The rest of the connectors are free to be used. Note that each was chosen to address various operational use cases defined by the SOSA working groups. Picking 3 examples, we have the 19-contact 19 SMPS connector module on the left, the dual hybrid 2 style C insert and 20 nano RF contacts connector module in the middle, and on the right we have the 2 style D inserts optical connector with 6 MT connectors. Each connector module with coaxial contacts has a table that outlines the defined functionality for the contacts. These functions are driven largely by the Modular Open Radio Frequency Architecture, or MORA standard. Note, however, that some allow for user-defined functions. Essentially, one would pick a column from the table and implement their board and system as directed. Note that the use cases that drove these tables could be somewhat complex. To help a board vendor or system integrator to make the right choices from the table, the SOSA technical standard includes decision trees to manage that complexity. AMPS is a methodology defined in VITA 65.0 for documenting exactly how a particular vendor's card is implemented. SOSA expanded AMPS to include additional information about the connector modules installed and how they are used. AMPS already has a field to specify which connector module is installed. SOSA added fields to indicate what protocols are implemented on any optical links and what configuration from the connector module table was implemented for the coaxial contacts. What this all means is that SOSA has constrained OpenVPX connector modules to a minimum practical set based on well-studied use cases. A minimum set of protocols for optical and functional assignments for the coaxial contacts have also been established, albeit with some user-defined pins, and AMPS was extended to document connector module choices. The result is that coax and optical blind mate connectivity is easier to manage and more interoperable than was previously possible. Now let's switch gears and look at SOSA system and chassis management. The SOSA technical standard describes the System Manager module as being responsible for implementing functions necessary to manage the overall SOSA sensor system, its hardware and software infrastructure, and the security controls applied to it. The functions of the System Manager module are basically discovery, configuration, control, health management, and security management. The System Manager applies these functions to SOSA modules, system hardware, software infrastructure, security controls, and the interface to the host platform. Note that the System Manager does not manage or control the mission, tasking, or operational aspects of the SOSA sensor. It is really focused on the health and well-being of the SOSA hardware and to some extent the software that comprise the platform. Essentially, it takes care of the SOSA sensor itself so it can implement the mission. VITA 46.11 is the core of the chassis management portion of SOSA system management. It provides an out-of-band mechanism for monitoring and controlling elements within the chassis, including plug-in cards, power supplies, fans, and sensors. VITA 46.11 is, itself, based on an earlier standard called IPMI, along with elements of the PICMIC Advanced TCA-based specification. But it adds numerous enhancements and defines a VITA 46.11 specific command set. VITA 46.11 essentially defines two basic components connected by a bus known as the IPMB, or radial IPMB connections. The Chassis Manager, which contains a chassis management controller, is the heart of the management system. It, in turn, communicates with Intelligent Platform Management Controllers, or IPMCs, on each plug-in card. The Chassis Manager monitors and controls all IPMCs in the system through commands transmitted across the IPMB. A board's IPMC is responsible for executing these commands issued to it by the Chassis Manager. Looking at the SOSA module architecture, we see the module 1.1 System Manager. This module is actually composed of several subcomponents, including the System Manager module software with in-band communication channels to other SOSA modules and hardware elements. The in-band links to the hardware elements are where the higher-level management and control of the chassis and plug-in cards take place. Looking more closely at this section, we see that the plug-in cards and the chassis management hardware and associated infrastructure can be thought of as two separate, distinct components. Note, too, that they are linked through the out-of-band IPMB bus shown on the right. Looking at the physical layout of the system and how all this works, we start at the System Manager on the right. It's shown as a cloud because it's not a physical component. It's software running somewhere, either inside or outside the system. It communicates to the Chassis Manager through the in-band communications link, typically the system control plane. The Chassis Manager is a piece of hardware running specific chassis management software and is connected to IPMCs on each of the plug-in cards by the IPMB, which is usually implemented as two buses or radial links for redundancy. The Chassis Manager also communicates with and controls various sensors, through information, and devices like fans scattered throughout the system through dedicated links. System management brings many benefits to SOSA systems. For instance, the out-of-band links can inventory the chassis contents to detect any unexpected changes and act appropriately. It can also control the power state of any plug-in card. This allows it to sequence board bring-up to manage inrush currents and can even depower misbehaving plug-in cards. It can also perform board or whole system resets. Lastly, it provides centralized access to board level and chassis sensors, manage various policy settings for board or system resources, and perform diagnostics or read the latest test results. The in-band links can perform detailed configuration or built-in testing, access various system logs, manage health and security status, perform zeroization or sanitization, or perform software or firmware updates. Thank you for watching. Please be sure to like and subscribe, and watch for more videos in this series.